Hey, it's Guy here. So, have you ever wondered how much things like sight, sound, scent, taste, and touch influence our perceptions of the world around us? Well, today's show is called The Five Senses, and it explores some of the ways our senses help construct our reality. And this episode originally aired in January of 2017. This is the TED Radio Hour. Each week, groundbreaking TED Talks.
TED Talks.
TED.
Technology.
Entertainment. Design.
Is that really what it stands for? I've never known that.
Delivered at TED conferences around the world.
The gift of the human imagination.
We've had to believe in impossible things.
The true nature of reality beckons from just beyond.
Those talks, those ideas, adapted for radio. From NPR. I'm Guy Raz, and on the show today, ideas about the five senses: smell, touch, taste, sight, and sound. And though we might think our senses help us experience reality as it is, most of the signals they send are personal and highly subjective. And it means the way each of us perceives the world around us is unique. So let's start with sound. I want to play sound for you, Wanda. Can you tell me what this is?
That is a GRB, right?
What's a
what you're playing.
What's a GRB?
It's a gamma ray burst.
This is Wanda Diaz Merced. She's an astronomer.
I'm from Puerto Rico.
And that sound she just described, the gamma ray burst, that would become a key that unlocked a whole world that was closed off to Wanda. And the story of how that happened starts when she was about 19. Wanda was a student at a college in Maine where she was super into science.
I was doing my physics and my mathematics, but at the back of my head, my thought was, I will become a doctor, like a general practitioner.
But around this time, Wanda started having problems. In the mornings in class, her friends would ask her why her hair wasn't done quite right. She also started tripping a lot. She'd have scrapes all over her knees. So she went to see a doctor.
When I go to the doctor in Maine, it's because I'm already having blind spots. So
you just start to notice blind spots in your visual field?
Yes.
Wanda was born with diabetes, and it turned out, because of a rare complication, the disease was slowly destroying her retinas.
And then we began the treatment and so on and so forth.
But the treatment was just delaying the inevitable. By the time Wanda turned 29, she was completely blind. But all this time, she never abandoned her passion for physics and math. And even though she gave up on the idea of becoming a doctor, she found another passion, which was astronomy. And Wanda decided she wanted to study the cosmos. But as she explained on the TED stage, her blindness made it impossible for her to read any astronomical data.
On the left, you will be seeing...
Wanda showed a series of data points plotted on a graph, which was data from a dying star.
Early during my career, I could also see this kind of plot. But then I lost my sight, and with it, I lost the opportunity to see this plot. And professionally, it left me without a way to do my science. I longed to access and scrutinize this energetic light and figure out the astrophysical cause. I wanted to experience the specious wonder, the excitement, the joy produced by the detection of such a titanic celestial event.
And this is the point in Wanda's story where she began to find hope.
I had a very good mentor. His name is Robert Candy at NASA Goddard Space Flight Center. He was the one who brought me to my first internship, and he was the one who...
Wanda says Robert Candy just saw her blindness differently. He challenged her to come up with a way for blind researchers to get more familiar with some of NASA's astronomical data.
And I said, I'm not going to just get familiarized with the data. I want to do science. I want to do some physics.
What Wanda realized was that the graphs of data most scientists look at, those are just numbers put to a page, plotted out over time, the rise and fall from left to right. And so what if, she wondered, what if she could instead plot that same data into sound, rising and falling, but in pitch. So with a lot of hard work and some computer programming, she did. This, believe it or not, is the sound of radiation from a star. On a graph, it would look just like a squiggly line. Lots of data points, some spikes higher than others. And Wanda found a way to turn those spikes into noise.
A lot of spikes going up and down.
And so just like sighted researchers, Wanda was able to study a graph and listen for data points out of normal range. When she hears those sounds, she knows she's found something important in the data.
Because when I'm observing or when I'm listening, it's like a vigilance task. I keep vigilant for the unexpected.
So after Wanda did this for the first time, she analyzed her results and then she nervously brought them to her mentor.
I sent him an email and my legs were shaking. And when he told me that he thought that I was right and to move it ahead, and then linked me to other professionals to continue moving the research forward, to me was like an epiphany.
I achieved access to the data, and today I'm able to do physics at the level of the best astronomer using sound. And what people have been able to do, mainly visually, for hundreds of years, now I do it using sound. Listening to these gamma ray bursts that you're seeing on the screen. Now I'm going to play the burst for you. It's not music, it's sound. This is scientific data converted into sound, and it's mapped in pitch. The process is called sonification.
It's actually beautiful. It's a beautiful sound. Can you...
Yes.
What does a gamma ray look like in space? I mean, no one has ever seen it, a sighted person or a person without sight, but we can all probably imagine what it looks like based on the data, right?
It will look or it will feel as a beam of energy. It's a massive outburst of energy in one direction, so massive that I don't think any eye would be able to resist such a view. Your retina will detach instantly if you see that kind of brilliance.
So don't get me wrong. I mean, the sound of the gamma ray burst is beautiful, but I have a hard time hearing the data in it.
Yes. In Buddhism, there's a saying that says that the voice does the Buddha's work, right? It conveys the heart.
Yeah.
So when you hear these sounds, it's like listening to someone talking to you. When I hear someone talking, and I guess most blind people and people that are not visually oriented, they can tell if the person is sad or if something has happened to that person, if the person is angry, etc. It's the same thing with this sound. And you feel that something is being communicated to you, that you're just perceiving it, and it makes me feel good. It makes me feel great.
The body is something changeable. Anyone may develop a disability at any point. And let's think about, for example, scientists that are already at the top of their careers. What happens to them if they develop a disability? Information access empowers us to flourish. When we give people the opportunity to succeed without limits, that will lead to personal fulfillment and prospering life. And I think that the use of sound in astronomy is helping us to achieve that and to contribute to science. I think that science is for everyone. It belongs to the people, and it has to be available to everyone because we are all natural explorers. I dream on a level scientific playing field where people encourage and respect each other, where people exchange strategies and discover together. If people with disabilities are allowed into the scientific field, an explosion, a huge titanic burst of knowledge will take place, I am sure. That is the Titanic burst. Thank you. Thank you.
Astronomer Wanda Diaz Merced, you can see her full talk at TED.com. On the show today, ideas about the five senses and how they help us perceive our own version of the world around us. So taste is a sense that's great, right? It's like the pleasure sense. But is it actually as important as the others? I mean, we could live without it, right?
Heresy, Guy. Heresy. Taste is the last barrier to you putting something in your mouth that could go in your stomach and poison you.
Okay, but pretty important.
Yes.
This, by the way, is
Dr. Nicole Garno.
And Nicole is a scientist at the Denver Museum of Nature and Science, where she studies taste.
It is the last line of defense our ancestors, in terms of evolution and survival, used to ensure that they stayed away from things that were going to kill it. And they made sure that they swallowed things they needed, like protein and carbohydrates, fats, salt.
Taste is not a frivolous sense.
It is not a frivolous sense. It should be taken very seriously.
Right, yeah, sorry.
And also with a lot of fun.
So just like there are five senses, most scientists believe there are five tastes. And each one plays a very different role in keeping us alive, as Nicole explained on the TED stage.
We're going to start with the one that we like the least, and that's bitter. We're born not liking bitter. And that's because bitter equals poison in terms of survival. But we can learn to like bitter things once we realize they're not poison, and a great example is caffeine, coffee. So let's go to the other end of the spectrum. We love sweet because it is the taste of pure energy via simple carbohydrates like sugar. Now, similarly, we love umami. Umami is the savory taste of protein, another thing we need for our bodies to survive. All right, now we're going to talk about a funky one, and that's sour, because it can either help us or harm us. So we tend to like weak acids like citric, and that's probably because we've evolved to need to like that so that we get vitamin C. But we do not like strong acids, like that in a car battery, right? That's going to kill us. We're not going to consume that. So the final one is salt. When your body needs salt to maintain fluid levels or other internal processes, we crave it. All right, so I just laid out for you taste. Taste is pretty logical and pretty straightforward when it comes to survival. I think it's too simple, actually. So I want to throw a wrench in what you think you know about taste. If evolution and survival are so complicated, as we know they are, why would taste be so simple? So I was curious about this, and I asked the question, why 5?
There could be a sixth taste?
There could be a 6th, 7th, 8th, so on and so forth. In terms of where the evidence lies, the one that seems to be the closest to really convincing sensory scientists across the world that it exists is fat taste.
Fat?
Fat taste is probably the 6th taste.
In just a moment, the hunt for the mysterious 6th taste. Stay with us. Today on the show, ideas about the 5 senses. I'm Guy Raz, and you're listening to the TED Radio Hour from NPR.
Hey everyone, just a quick thanks to 2 of our sponsors who help make this podcast possible. First, to Starbucks, introducing new Starbucks Plus Coffee K-Cup pods. With twice the caffeine compared to 1 pod of Starbucks K-Cup coffee, it's an extra boost to help you make the most of your day. So get up, get going, and get 2 times the caffeine with new Starbucks Plus coffee, the coffee that keeps up with you. Available in Starbucks Blonde, Medium, and Dark Roast K-Cup pods for the rich taste you love. Look for the new Starbucks Plus coffee wherever you buy groceries. Thanks also to SimpliSafe. SimpliSafe is thoughtfully designed home security. It was created in collaboration with leading design firm IDEO, and they put a lot of care and attention into every detail. From beautiful sensors that disappear into your home to gentle reminders if you accidentally leave a window open. It's an intuitive system, home security you'll actually want in your home. Plus, when you order your system, SimpliSafe will also donate one to a family in need. Learn more at simplisafe.com/radio hour.
There's a new way to hear Morning Edition, All Things Considered, and all your favorite programs. Just ask your smart device to play NPR. Listen to your local station anytime, like this. Hey, smart device, play NPR.
It's the TED Radio Hour from NPR. I'm Guy Raz. And on the show today, ideas about the five senses. And we were just hearing from Nicole Garno, who studies taste at the Denver Museum of Nature and Science, where she, like some other scientists in the budding field of taste research, thinks that fat might be the mysterious sixth taste.
When I say fat, what do you think about?
I think of just big pieces of fat off a piece of meat. Just, congealed fat from the meat that cooked in a pot.
So this is the problem with taste science, is that it is dependent in a lot of ways on language. And so when I say fat, I'm thinking of the actual molecules, the fatty acids, the good fats, right? Omega-6, omega-3. So the fatty acid that we study is linoleic acid, and it is in meat, nuts, vegetables. It's something that your body needs to eat almost every day to survive because our bodies can't make it.
So what does it taste like?
It's actually a pretty gross taste. It's like, for me, it's kind of like stale popcorn in a bag that got left in your car, maybe with some melted plastic on it.
Ugh.
Not tasty. No.
So I'm out to prove that fat is the sixth taste. And in order to do that, you have to answer a lot of questions. But the one that's most intriguing to me as a geneticist is this. Is there a gene for fat taste? So, your ability to taste is wrapped up in tens of thousands of years of your family history through evolution. And all of that evolution is written today, right now, right in you, in your DNA. So if you think about your DNA like a cookbook for your body, then like any good cookbook, your DNA cookbook has genes. These are recipes, right? So recipes or genes, same thing. They are the instructions telling your body how to make something it needs to survive. And to tie it back to taste, my goal is to find the gene or recipe for fat taste. So I'm gonna need thousands of people to come into my lab to do taste tests, to answer questions about themselves, and to do a cheek swab, kind of like the CSI shows, except for we're gonna use it to study taste genes.
Nicole and other scientists are working on this right now, and they've already begun to prove that fat is a taste we can detect.
And we have a paper published that shows as we increase the amount of fat in a taste solution, people can actually tell us that it's been increased, even when we do it in a double-blind study and don't tell them what's in it. But there's a lot of other work that needs to be done, and I am fully supportive of it. And I think that it's going to show that fat taste is real.
How would it change our understanding of taste if fat is recognized as a sixth taste?
Taste research is being done to understand so much in terms of nutrition. And so the more we can understand about how our bodies work, and if fat is part of that, if fat taste is part of that, then I think the smarter we can be about, well, how do you create recipes that are healthy, that somebody actually wants to eat? Or how do we make drugs that, potentially have, like a lot of drugs are bitter. So how can you make drugs that are bitter offset that so that like kids can take it and they can get better if they need that drug? And so that's just one more piece of the equation. It's not an end all to us solving like a problem around obesity by any means, but it is something that we need to consider in terms of how our bodies work in modern day life, which is modern day life is not how our bodies evolved to live.
I have to assume that over time our taste evolves pretty radically. Like if you were to take a Neolithic human, right, and drop them into 21st century Earth, they would freak out because they would taste things and it would just be so crazy to them, right?
So taste preference is innate. So we are born liking sweet. We are born not liking bitter. That's in all of our DNA for the most part. Unlike smells, like there's no smell that everyone loves or there's no smell that everyone hates across the world. Huh. But taste, we really have this. So if you dropped somebody from Neolithic times into our time, they would probably still like sweet and probably still not like bitter.
Huh.
The thing that I love around taste and flavor research in this day and age is how much we are now seeing this cultural mixing of the foods that we eat, no matter where you are in the world. And so the ideas behind it is how, as humans, do we think about what we have innate preferences for, but then be food adventurous enough to survive in a world that's actually much more diverse than the little world that we live in.
Nicole Garneau is a curator at the Denver Museum of Nature and Science. You can see her full talk at ted.npr.org. Today on the show, ideas about the five senses. So before we get started, you were the guy who played Weasel Wiesel on Saved by the Bell?
That's right.
Would you call that like the pinnacle of your achievements?
I would call that an awful television show that I had a lot of fun being on.
Did you continue to act after that role?
No, so around this time, by my mid to late teens, my sight was becoming a substantial nuisance. Probably by my early 20s, it was a disability, and by the time I was 25, I was blind.
Isaac Lidsky might have been on track to turn a successful run as a child actor into a lifelong thing. But at age 13, he was diagnosed with a genetic disease that caused the cells in his retina to progressively die off.
So progressive deterioration of your sight and ultimately blindness. Sitting in the car on the way home from that doctor's office, I knew that blindness was going to completely ruin my life.
You thought that at age 13?
I didn't think it. I knew it. I knew it. It was my reality.
But blindness didn't ruin Isaac's life. In fact, he ended up graduating from Harvard. He got a law degree, even worked for 2 different Supreme Court justices. And today, he runs his own successful business. But back when he was a kid, to see that path forward, Isaac had to grapple with what it meant not to see at all. Here's Isaac Lidsky on the TED stage.
What does it feel like to see? You open your eyes and there's the world. Seeing is believing, sight is truth, right? Well, that's what I thought. Then, from age 12 to 25, my sight became an increasingly bizarre carnival funhouse hall of mirrors and illusions. Objects appeared, morphed, and disappeared in my reality. It was difficult and exhausting to see. I pieced together fragmented, transitory images until I saw nothing at all. I learned that what we see is not universal truth. It is not objective reality. What we see is a unique, personal, virtual reality that is masterfully constructed by our brain. Let me explain with a bit of amateur neuroscience. Your visual cortex takes up about 30% of your brain. That's compared to approximately 8% for touch and 2 to 3% for hearing. Sight is 1/3 of your brain by volume and can claim about 2/3 of your brain's processing resources. It's no surprise then that the illusion of sight is so compelling. But make no mistake about it, sight is an illusion. A hill appears steeper if you've just exercised, and a landmark appears farther away if you're wearing a heavy backpack. You create your own reality and you believe it. I believed mine until it broke apart. The deterioration of my eyes shattered the illusion. You see, sight is just one way we shape our reality. We create our own realities in many other ways. Let's take fear as just one example. Your fears distort your reality. Psychologists have a great term for it, awfulizing, right? Fear replaces the unknown with the awful. When I was diagnosed with my blinding disease, I knew blindness was a death sentence for my independence. It was the end of achievement for me. Blindness meant I would live an unremarkable life, small and sad, and likely alone. I knew it. This was a fiction born of my fears, but I believed it. If I had not confronted the reality of my fear, I would have lived it. I am certain of that.
So how did your reality change?
So, I tell the story of the first time that I visited with a low vision and blind occupational therapist, a vision rehabilitation specialist. And she started to talk about all these practical solutions for discrete problems. In the back of my mind, I was actually a bit frustrated.
You were thinking, I don't want to hear this.
Yeah, yes, I bump into things. Yes, maybe I should learn to use a cane, but that's almost arbitrary. Like, I'm here to talk about blindness, this amorphous boogeyman that's going to ruin my life. I'm not here to talk about these practical details. And then it really hit me. There is no amorphous boogeyman. There is no overarching, doom and gloom. All it is these practical problems that she wants to talk about. And that was a major change for me. I decided right there that whenever I felt afraid, I'd ask myself 2 questions. What precisely is my problem? And what precisely can I do about it? I knew blindness was going to ruin my life, but that was a reality that I was choosing, that my mind had created for me, and I was choosing to believe. And I decided to make another choice.
Vision, right? I mean, it's such a powerful and dominant sense. I mean, it overpowers our other senses.
Well, there's no doubt that we are inherently visual creatures, and it dominates our mental capacity and our processing power. And in some ways, it does that, I think, to our great detriment. At least in a couple ways. There's a lot more going on in the world around us than light striking the photoreceptor cells of our retinas. But we are built to certainly devote an inordinate share of our attention to that light. At the end of the day, our photoreceptor cells respond to about 1/10 trillionth of the spectrum of light in the world around us. And from that 1/10 trillionth of light flying around, our brains concoct this scenario that implicates our memories, our opinions, our emotions, our experiences, and sort of conceptually how we understand the world. And then we believe that is what the world, quote unquote, looks like. The assumption we make is that the entire point of our visual system, the way it's constructed, its goals are to represent the world around us accurately.
Yeah.
It turns out, science is starting to show us that that's not true. The point of sight is to be useful to us in the same evolutionary way that we endeavor to, fulfill objectives of, procreation and survival. So the system isn't even designed to represent the information accurately. It's designed to be helpful in the evolutionary goals.
How much of our reality, of what we see, is an illusion?
So I would argue all of it. To me, it's more about choosing what reality you want to live for yourself. So this really was the profound insight that really made losing my sight a great blessing in my life. I felt I was living a race against the clock, a race against time, a race against blindness, until I decided to really take control of my own reality.
My point today is not about my blindness, however. It's about my vision. Going blind taught me to live my life eyes wide open. It is a learned discipline. It can be taught. It can be practiced. I'll summarize very briefly. Hold yourself accountable for every moment, every thought, every detail. See beyond your fears. They are your excuses, rationalizations, shortcuts, justifications, your surrender. Choose to see through them. Choose to let them go. You are the creator of your reality. With that empowerment comes complete responsibility. I chose to step out of fear's tunnel into terrain uncharted and undefined. I chose to build there a blessed life. Far from alone, with Dorothy, my beautiful wife, with our triplets, whom we call the Tripskis, and with the latest addition to the family, sweet baby Clementine. Helen Keller said that the only thing worse than being blind is having sight but no vision. For me, going blind was a profound blessing because blindness gave me vision. I hope you can see what I see. Thank you.
That's Isaac Lidsky. His book about this is called Eyes Wide Open. You can see his full talk at TED.com. On the show today, we're exploring ideas about the 5 senses. And next up, smell. So you know how some people get more mosquito bites than others?
Oh, yes.
The reason is smell.
Because we give off different smells.
We give off different smells that mosquitoes are attracted to.
There is a group in the UK that's been wrapping people up in silver foil, collecting the smells and seeing if the smells attract mosquitoes. And what they found is that, yes, some people are much more attractive than others.
This, by the way, is Professor Tristram Wyatt.
I'm based in the zoology department at the University of Oxford.
And Professor Wyatt, he studies smells.
Indeed. And my interest is in animals right the way across the animal kingdom through to people.
And he says, just like people smell different to different mosquitoes, lots of things smell different to different people.
Each of us does smell a different world. Because when we're smelling, say, strawberries, there are hundreds of different smell molecules that have been given off by the strawberries. And what our brain is very good at is interpreting the many nerves that are stimulated by those different smells and remembering, that strawberry.
And the amazing thing is that it's only in the last 30 years that scientists have really understood how smell works. Tristram Wyatt explains from the TED stage.
Smell was the hardest of the senses to crack, and the Nobel Prize awarded to Richard Axel and Linda Buck was only awarded in 2004 for their discovery of how smell works. It's really hard. But in essence, nerves from the brain go up into the nose, and on these nerves exposed in the nose to the outside air are receptors. And odor molecules coming in on a sniff interact with these receptors, and if they bond, they send the nerve a signal which goes back into the brain. We don't just have one kind of receptor. If you're a human, you have about 400 different kinds of receptors. And the brain knows what you're smelling because of the combination of receptors and nerve cells that they trigger, sending messages up to the brain in a combinatorial fashion. But it's a bit more complicated because each of those 400 comes in various variants. And depending which variant you have, you might smell cilantro, that herb, either as something delicious or something like soap. So we each have an individual world of smell, and that complicates anything when we're studying smell.
I mean, it's crazy to think that, some of us taste this delicious herb that I just used last night in my guacamole, and then some of us taste soap.
Yes, it turns out that about 20% of people have a different version of the smell receptor. It's just simply a matter of genetics.
Wow.
Now, we're familiar with colour blindness, and that's just with 3 receptors, the red, green and blue. Well, imagine what's going on in the nose, where you have 400 receptors, and quite a few of those come in different forms that might or might not work for a particular kind of smell. Which means that the solution is don't add cilantro to all of the guacamole you're producing.
Yeah.
And an enterprising cafe in California offers 2 versions.
Okay, so that's how humans smell things. But what about what we smell like? Of course, there's sweat and the way a baby's head smells, but there's one human smell scientists have not been able to find.
Pheromones.
Pheromones, what most of us think of as the scent of attraction. And in just a minute, we'll hear about the scientific quest to find it. On the show today, we're exploring ideas about the 5 senses. I'm Guy Raz, and you're listening to the TED Radio Hour from NPR. Hey everyone, just a quick thanks to 2 of our sponsors who help make this podcast possible. First, to Rocket Mortgage by Quicken Loans. Rocket Mortgage gives you the confidence when it comes to buying a home or refinancing your existing home loan. Rocket Mortgage is simple, allowing you to fully understand all the details and be confident you're getting the right mortgage. To get started, go to rocketmortgage.com/ideas. Jessica?
Equal housing lender. Licensed in all 50 states. NMLS-ConsumerAccess.org number 3030.
Support also comes from the American Petroleum Institute. The natural gas and oil industry is becoming more high-tech every day through innovative technologies such as 3D mapping and machine learning. The energy industry is committed to environmental progress and building a better future. To learn more about how natural gas and oil are turning brain power into horsepower, text ENERGY to 73075.
Gatsby's Netflix comedy special, Nanette, is a cultural phenomenon, and Pop Culture Happy Hour is talking about it with special guest Kumail Nanjiani, who knows his stuff when it comes to comedy. Hear the episode wherever you get your podcasts.
It's the TED Radio Hour from NPR. I'm Guy Raz. And on the show today, ideas about how our senses shape our perceptions of the world around us. And we were just hearing from Oxford zoologist Tristram Wyatt about smell. He's been studying one aspect of smell from the animal world that we know far less about when it comes to us: pheromones. Here's Tristram on the TED stage.
Pheromone. It conjures up sex, abandon, loss of control. And you can see it's a very powerful word. Now, if you put that word into the web, as you may have done, you'll come up with millions of hits. And almost all of those sites are trying to sell you something to make you irresistible for $10 or more. Now, this is a very attractive idea. And the molecules they mention sound really sciencey. They've got lots of syllables. It's things like androstenol, androstenone, androstenedienone. And when you combine that with white lab coats, you must imagine that there is fantastic science behind this. But sadly, these are fraudulent claims supported by dodgy science. So the ancient Greeks knew that dogs sent invisible signals between each other. A female dog on heat sent an invisible signal to male dogs for miles around, and it wasn't a sound, it was a smell. You could take the smell from the female dog, and the dogs would chase the cloth. And it was only in 1959 that a German team, after spending 20 years in search of these molecules, identified the first pheromone, and this was the sex pheromone of the silk moth. Adolf Butenandt and his team created the model for how you should go about pheromone analysis. He basically went through systematically, showing that only the molecule in question was the one that stimulated the males, not all the others. He synthesized the molecule and then tried the synthesized molecule on the males and showed it was indeed that molecule. That's closing the circle. With that new concept, we needed a new word, and that was the word pheromone. And it's basically transferred excitement, transferred between individuals. And since 1959, pheromones have been found right the way across the animal kingdom. In male animals, in female animals, it works just as well underwater for goldfish and lobsters. And almost every mammal you can think of has had a pheromone identified. That's the thing which has never been done with humans. Nothing systematic, no real demonstration.
How is it that we have discovered pheromones in virtually, across the animal kingdom, but we just can't figure it out in humans? What's the problem?
I think partly it's we've not looked seriously. And that is strange. But generally speaking, if you look at things like NIH funding, there is much more going towards vision and hearing, and relatively small amounts of money go towards studying smell. And pheromones would come under that area of research. The other thing is that generally, studying pheromones in mammals is much harder. And that's because mammals, including us, are incredibly smelly. And that means that if you start looking at the smells, you become overwhelmed by the number of potential molecules.
Wow.
So if you look in somebody's armpit, after asking them first,
of course,
and count the different kinds of molecules, there are hundreds, if not thousands. And that complicates things because you don't know at the beginning which molecules to look at.
So what are scientists looking for, exactly when they're searching for pheromones?
So pheromones are chemical signals, something that has evolved for communication. So the way you find a pheromone is by looking for the molecules that stay the same in every male or every female, molecules that are consistent. And the rest, that's individual odors. Now, some may have more of that molecule than others, and so it's almost the success of the smelliest.
Are we getting closer to finding them, to identifying human pheromones?
We actually do not know any sex pheromones. but at some point we may well find them. But there is another pheromone that is actually really exciting, and it's all to do with mothers and babies. And it's some work that's coming out of France, from Dijon, and they found something really neat.
So this is a baby having a drink of milk from its mother's breast. But what you'll notice is a white droplet, and that's a secretion from the areolar glands. Now, we all have them, men and women, and these are the little bumps around the nipple. And if you're a lactating woman, these start to secrete. It's a very interesting secretion. So this is a sleeping baby, and under its nose, we've put a clean glass rod. The baby remains sleeping, showing no interest at all. But if we go to any mother who's secreting from the areolar glands, if we take this secretion and now put it under the baby's nose, we get a very different reaction. It opens its mouth and sticks out its tongue and starts to suck. Now, since this is from any mother, it could really be a pheromone. It's not about individual recognition. Any mother will do. Now, why is this important, apart from being simply very interesting? It's because if you're a mammal, the most dangerous time in life is the first few hours after birth. You have to get that first drink of milk, and if you don't get it, you won't survive. You'll be dead. Since many babies actually find it difficult to take that first meal because they're not getting the right stimulus, if we could identify the molecule, synthesize it, it would then mean premature babies would be more likely to suckle and every baby would have a better chance of survival. This is one example of where a systematic, really scientific approach can actually bring you a real understanding of pheromones. There could be all sorts of medical interventions. There could be all sorts of things that humans are doing with pheromones that we simply don't know at the moment. So do go forward and do search for more. There's lots to find. Thank you very much.
Tristram Wyatt, he's a senior researcher at Oxford where he studies smell. You can see his entire talk at TED.com. Today on the show, ideas about the five senses. And we've now made it through sound, taste, sight, and smell, which leaves touch.
There are things we don't understand about all the senses, but touch has been particularly underexplored. If you look in the scientific literature, you'll find probably 100 papers on vision for every one about touch.
This is David Linden.
I'm a professor of neuroscience at Johns Hopkins University School of Medicine.
And so, as a neuroscience professor, David researches how our brain processes all of the five senses. But he says touch gets the least attention.
Part of it is a failure of imagination. Sighted people can close their eyes and kind of imagine what it would be like to be blind, or we can plug our ears, and we can imagine what it's like to be deaf.
Right.
But there's no way to imagine losing your sense of touch. And I think that makes it somehow less compelling.
But David says it shouldn't be. Here he is on the TED stage.
We know that if you're born blind, without sight, that you can develop a great mind and a great body and have a great life. And likewise, if you're born deaf, you can develop a great mind and a great body and have a great life. But if you're born with the biological components for a sense of touch, but you do not receive touch during your infancy, and when you're a toddler, then a disaster unfolds. And we know this mostly from what happened in orphanages in Romania during the Ceausescu regime in the 1970s and what followed in the 1980s. And these were situations where there were grossly understaffed orphanages. There was no one to hug or hold or be loving in a tactile way towards these children. And they developed horrible, compulsive, self-soothing rocking motions. Later, they had attachment disorders, cognitive delays. And it wasn't just neuropsychiatric problems. Their growth was stunted, and they had problems with the development of their gastrointestinal systems and their immune systems. And we know that this is because of touch deprivation, because in some cases, volunteers came in and gave just 30 minutes a day of loving touch, a little hugging, a little limb manipulation, and that was enough to completely reverse all of these deleterious effects, but only if it occurred in the first 2 years of life. If the intervention came after age 2, all those problems would persist for the rest of life.
Why? I mean, what explains it? I mean, it seems strange that this external experience, that someone touching you or you touching something else, would have internal implications.
It is strange, and the truth, the embarrassment for biologists is that we don't understand it. In other words, I wish I could give you a pathway of cells and molecules that went from loving touch to proper development of the gastrointestinal or immune system, but we don't understand that.
Is touch real, or is it an expression of a signal that your brain is sending to you?
Well, all sensation, whether it's vision or touch or hearing or what have you, only occurs in the brain. So if you interrupt the pathway from the body to the brain, as can occur, for example, in spinal cord injury, then those sensations won't occur. That doesn't make it, to my mind, any less real, but it does point out the fact that our sensations, touch included, are actively constructed in our brains, and our brains work not to give us the most accurate representation of the external world, not the pure, unalloyed lowdown, but they are spinning the data. They are ignoring some information and emphasizing others, and mixing the stew together in a way that the brain thinks through evolution will be most useful.
Imagine that you're walking down the street, and as you walk down the street, you're moving your limbs and your torso, and your clothes are moving against your body, and you're not thinking about it at all. It doesn't enter your consciousness one bit. Those sensations are strongly suppressed. Whereas, if you imagine you're stopped on the street corner, and now those same sensations come on your body, you'd be very attentive to them. They would have great salience. It's because we're hardwired to suppress the sensations that result from our own motion. And this makes evolutionary sense, right? Because the outside world, that's where the things are that we might want to eat, that we might want to mate with, that we might want to run away from. So we want to pay more attention to the outside world than to the consequences of our own motions. And the crucial medical issue that is tied up with this is why it is that it's so very hard to tickle yourself, right? So when you go to tickle yourself, electrical signals are flowing from the motor cortex in your brain down to the muscles of your arm and your hand to produce that tickling motion. But a copy of those signals is going to a part of the brain called the cerebellum. And the cerebellum transforms those into inhibitory signals and suppresses those sensations.
I wonder, aside from the biology, there's a social aspect to touch, right? Does touch affect how we think about other people, like how we interact with other people?
Absolutely. We are specialized by many years of evolutionary history to extract social information from interpersonal touch. It is incredibly dependent upon social context, and it's incredibly dependent on cultural contexts. This was really revealed by Sidney Girard, a psychologist who liked to spy on people in cafes in the 1960s, and he would go all around the world. And he would find that in San Juan, Puerto Rico, people would touch each other on the order of 200 times in an hour. These weren't just lovers. These would be friends or colleagues from work.
Yeah.
And then he would do the same thing in Paris 40 times an hour, and in New York City 2 times an hour, and in London 0 times an hour. And this just points out that there's a lot going on that isn't just hardwired into our biology. Our social, cultural expectations about touch really influence how we feel about it.
That's amazing. It hews to a kind of a cultural stereotype that we have, that people in Latin America are warmer and more generous and friendlier, and the more sort of north you get into Europe, people are colder and less willing to engage right away.
That's right. And there are other places where there is a lot of social touching allowed within the sexes, but between the sexes, it's completely banned outside of small children or marriage. I think the crucial thing to keep in mind is that the way we experience touch is utterly dependent upon context. Imagine you're having an argument with your sweetheart, and then your sweetheart reaches out and strokes your arm in the middle of the argument, but it's not resolved. How does that feel? It doesn't feel good at all. It feels unwanted. Now imagine the very same touch on your arm, the very same pressure, velocity from the very same person, but now in a loving, connected time. It feels completely different.
Yeah.
And it's not that the physical sensation is the same, and we just think about it differently afterwards. From the very first moment you're aware of that sensation, it feels differently. And that's because our experience of touch is conditioned by context.
Yeah. I want to ask about the vocabulary around this sense, because it's fundamental to the way we interact with each other, right? We say, I'm touched by your gesture, or my feelings get hurt, These words that we use that are so connected to this sense, what explains it?
Well, I think the important thing to realize is that this isn't just a quirk of modern-day English. You can go back in English, or you can look at many other languages around the world, not just from the Indo-European language group, and this construction is present not in every language, but very broadly around the world. So I think that is telling us something that is fundamental to being human, and that is there is a deep link between the sense of touch and emotion, and that link is hardwired in our brains.
David Linden, he's a professor at Johns Hopkins University in Baltimore. You can see his entire talk at TED.com. Hey, thanks for listening to our show on the 5 senses this week. If you want to find out more about who was on it, go to ted.npr.org. To see hundreds more TED Talks, check out TED.com or the TED app. Our production staff at NPR includes Jeff Rogers, Brent Bachman, Megan Kane, Neva Grant, and Sanaz Meshkinpour, with help this week from Casey Herman, Chris Benderev, Rachel Faulkner, Camilo Garzon, and Daniel Shukin. Our intern is Thomas Liu. Our partners at TED are Chris Anderson, Kelly Stetzel, Anna Phelan, and Janet Lee. If you want to let us know what you think about the show, you can write us at tedradiohour@npr.org. You can follow us on Twitter. It's at TEDRadioHour. I'm Guy Raz, and you've been listening to Ideas Worth Spreading right here on the TED Radio Hour from NPR.